Hi again, guys. We are going to do a lab called the Hydrate Lab, where we're going to drive off the water from a hydrated compound, or I'm going to, you're not, sorry, and try and figure out just how many water molecules are attached to our copper sulfate. Copper sulfate is a beautiful blue crystalline solid, really pretty, and also moderately toxic, so don't eat it. That's always the question. No, you can't eat it. I'm going to use a powder version of it so it's easier to get in my test tube. I'll be posting this document, and there is a pre-lab question. It's actually part of it's necessary to do the calculations later, and that's finding the molar mass of copper sulfate, copper 2 sulfate, and water. The procedures are going to be modified slightly. I'm going to use a test tube instead of the crucible as it states on the front of the document. But I'm going to go through the basics of the procedure and give you the information. So the first thing I'm going to do is find the mass of my empty test tube and beaker and record that. 68.54 grams. And then I'm going to zero it just to make my life easier and add the copper 2 sulfate. And again, it's a really pretty blue powder. Oops, there went some on the ground. Oh well. I'm going to add some to my test tube. I'm not going to add too much because it takes too long to heat. And it says 2.81 grams of my hydrated salt. The next thing we're going to do is we're going to light our burner and put the test tube in the test tube holder. Remember, when you're heating over anything in a test tube or an open container, you want to point it away from yourself, not at yourself. And you'll understand why here in just a second. Go ahead and light this. Get some more oxygen. Okay, and this might take a little bit of time, but I have to keep the camera rolling, so bear with me. So I'm going to start heating my compound. And you might be able to see there's condensation in the test tube already. I can hear a little hissing and fizzing as I'm heating it. And I'm going to heat up and down the whole length of the test tube because I want to get that water out of my sample. The hydrate does tend to clump a little bit. That's okay, but you can see, I'm sure, that that pretty blue color is going away. As the test tube itself gets heated up, you might be able to see some steam coming out of the mouth of the test tube. Also, sometimes a little bit of the copper gets carried with it, and sometimes you see a little blue if I put the, no, not this time. So I'm going to keep heating this, and it does, like I said, take a little bit of time, but pretty obvious that the compound is still losing water. You can see the steam coming off now, I hope. Let's get that baby cooking. If I knew how to splice videos, maybe I'll figure it out before the end of this quarantine thing, and I would do that, but I don't, so I have to keep it running. I apologize. I'll see if I can figure out how to speed it up before I post this. But we still got a lot of steam coming out. And obviously this test tube is a little bit dirty. There's something else in there. Usually the solid just ends up kind of looking gray. It's got a little bit of brown to it. I can still see some blue, so I gotta keep going. Sorry you don't get to do this. It's a lot of fun to cook things over the Bunsen burner. Still got steam coming out. So the salt, that's just a generic name for ionic compounds. The salt that is hydrated is a pretty blue, but the anhydrous, ANHYDROUS salt is kind of a gray-white color. Most salts are white in color. Copper sulfate is noticeably colored blue, so it makes it easy to tell when you've reached the end. I can still see some steam in the test tube, so I know I haven't reached the end yet. Blue in the middle, which is a problem. It doesn't always get all the way done. I'm going to call that good. It looks pretty good. Again, there was obviously something in the test tube. It shouldn't be brown in appearance, but this one is. So I'm going to turn off the burner and let it cool for just a moment. The heat causes convection currents, and so it can alter your readings a little bit. And so I want to give it time to cool off. We're not using the crucible, so it's not quite as critical. We've got the test tube. I'm going to put this back in. Zero. And for some reason I'm getting a low reading, which doesn't make any sense, probably because it's too hot. So I'll put it on the counter for a minute. I'll post what the anhydrous salt mass is, and then we'll go through on how to do calculations.